Welcome, fellow Kubernetes enthusiasts. Thank you for joining the session today. And of course, we will be talking about Kubernetes and specifically about securing the Kubernetes ecosystem. Taking a look at other talks that are going on here, certainly other professionals are showcasing different tools and talking about different aspects of Kubernetes. But what I want to talk about is really more securing the entire big picture of Kubernetes ecosystem, looking at how we can secure numerous moving pieces in the Kubernetes and building a secured Kubernetes clusters. Let me start by introducing myself. My name is Vasanth. Like many of you, I am a Kubernetes and security fanatic. My experience spans across various domains of information security, including cloud, container security, penetration testing, and DevSecOps. I'm also passionate about cloud and cloud native SecOps and security automation. Now that the intro is done, let's dive into more fascinating stuff, the world of Kubernetes. Kubernetes is hot in the DevOps space, is now the third most wanted platform among developers. Kubernetes is rapidly growing and evolving, and it is not just Kubernetes anymore. This is a landscape picture from CNCF. Every tiny picture is a product logo. A few years ago, Kubernetes was just a platform, but now it's a platform to build many other platforms. Getting started with Kubernetes is easy. It takes a matter of minutes to set up a new cluster and run applications. However, the real concern or challenge is what follows this, the pivotal question of how to make sure your cluster is secure. For any organization, security should be the primary concern and not an afterthought effect, because prevention is always better than cure. In fact, let me tell you exactly what happens in the real world when the Kubernetes clusters aren't secured properly. In mid-2019, second largest auto finance company in the United States was hacked, and huge amounts of credit card data, social security numbers, and bank account numbers of more than 100 million customers was leaked. Do you recall who this was? It was Capital One. And for this breach, Capital One was hit with an $80 million civil penalty. And world's famous automaker was one of the earlier victims of cryptojacking when a Kubernetes cluster was compromised due to an administrative console not being password protected. Can you guess who this was? It was Tesla. There are many other incidents like Microsoft's Kubeflow breach and Docker Hub incident last year where attackers managed to plant malicious images in the Docker Hub, causing anyone who uses those images to be cryptojacked. What this means is users unknowingly deployed cryptocurrency miners in the form of Docker containers that then diverted compute resources toward mining cryptocurrency for the attacker. A mistake done knowingly or unknowingly is always a mistake and can cost companies a lot, not just in terms of financial loss, but also reputational damage. Now, let's look at how we think about different Kubernetes components. Needless to say, Kubernetes follows a client-server architecture model, and a working Kubernetes deployment is called a cluster. We also know that if the control plane is the brain of the operations, the worker nodes are the muscles. And do you need to interact with your Kubernetes cluster? Talk to the API. The Kubernetes API is the front end of the Kubernetes control plane handling internal and external requests. Is your cluster healthy? If new containers are needed, where will they fit? These are the concerns of the Kubernetes scheduler. And Kubernetes controllers take care of actually running the cluster, and the Kubernetes controller manager contains several controller functions in one. And etcd is a key value store database designed to be the ultimate source of truth about your cluster. And what happens in Kubernetes nodes? The worker nodes are the muscles. They run and control all the pods and containers for your cluster. And each compute node contains a kubelet, a tiny application that communicates with the control plane. And a pod is the smallest and the simplest unit in the Kubernetes object model. It represents a single instance of an application. Now let's discuss how an attacker looks at the Kubernetes components. Well, the diagram shows that all communications go through the Kube API server. This is what defines and controls all of the Kubernetes management and operational functions. The Kubernetes API service acts as the front door to any cluster. It is generally exposed on every deployment since it is needed for management purposes. But exposing your API server to the public is the most common entry point for attackers. It is actually a really juicy target. Malicious actors will always try to get access to the Kube API server and the control plane, and once these are compromised, they can then proceed to compromising the whole cluster. At times, it may not be a bad day for just your cluster, but also for your cloud account or the underlying infrastructure where the cluster is running. The next one is etcd. etcd is a key value store and a core component of Kubernetes clusters, and it's the main data storage location for your cluster. This means that all of your cluster objects are saved here. In fact, etcd is considered the source of truth for Kubernetes. It is used to store highly sensitive configuration data, but it is also easily left unprotected. Anyone who gains access to etcd targets to retrieve service account tokens and secrets. Once, if an attacker has access to a privileged secret or a token, then it's game over. A very quick win for the attacker. In addition to stealing valuable secrets, attackers could also potentially change configuration data for various services. You have a host of ports to worry about. It's not just the etcd service and Kubernetes API that you need to be cautious about leaving exposed. Depending on how your cluster is configured, other services might cause you trouble if a hacker gains access to them. Now let's talk about the attacks on the node. Kubelet expose endpoints which grant powerful control over the node and containers when compromised. By gaining control of a kubelet, the attacker has gained unfettered access to the Kubernetes application. This is an endgame too. Kubelet is accessible via two ports, read-write and read-only port, and the container runtime. This component enables the functionality required to start, run, and manage containers on a given node. The container runtime is what executes containers and therefore is another prime target for attackers. I can't stress enough how important it is to secure your workloads or containers. A privileged container, when gained access, gives an attacker the privilege to run a command in the context of the container, the option to escape and access the host resources. This is an endgame too. An attacker who gains access to the container has gained access to your cluster and eventually the underlying account. A framework named MITRE ATT&CK Framework is a knowledge base of known tactics and techniques that are involved in cyber attacks. Azure Security Center started to map the security landscape of Kubernetes and created the first Kubernetes attack matrix comprising the major techniques that are relevant to container orchestration security with focus on Kubernetes. The matrix contains the 9 tactics as shown here. Each one of them contains several techniques that can be used by attackers to achieve different goals. Let's start with initial access. The initial access can be achieved directly via the cluster management layer, or alternatively by gaining access to a malicious or vulnerable resource that is deployed on the cluster. Or also it could be using cloud credentials, or the kubeconfig file, or even a vulnerable application. The next one is execution. The execution tactic consists of techniques that are used by attackers to run their code inside a cluster. It is like executing into the container. An attacker who have permissions can run malicious commands inside the containers. Or they can even run or deploy a new container in the cluster for running their malicious code. Or they could even take advantage of exploiting an application. Or it could be like an SSH server running inside the container. The next technique is persistence. This tactic consists of techniques that are used by attackers to keep access to the cluster in case their initial foothold is lost. It could be like deploying a backdoor container to run their malicious code, or using a writable host path mount, or even a Kubernetes cron job for scheduling execution of malicious code that would run as a container in the cluster. The next technique is privilege escalation tactic, which consists of techniques that are used by attackers to get higher privileges in the environment than those they currently have. In containerized environments, this can include getting access to the node from a container, or gaining higher privileges in the cluster, and even getting access to the cloud resources. It could be using techniques such as like cluster admin binding or host path mount. And the next one, the defense evasion tactic, consists of techniques that are used by attackers to avoid detection and hide their activity. Attackers may delete the application or OS logs on a compromised container in an attempt to prevent detection of their activity, or they may even delete the Kubernetes events. The next one is the credential access tactic, which consists of techniques that are used by the attackers to steal credentials. It could be like listing Kubernetes secrets, or mounting service principal onto the containers, or accessing container service account token, or application credentials in some configuration files. The next one is discovery. This tactic consists of techniques that are used by the attackers to explore the environment to which they gained access. This exploration helps the attacker to perform lateral movement and gain access to additional resources. And the next one is lateral movement tactic, which consists of techniques that are used by the attackers to move through the victim's environment. And the last one is impact. The impact tactic consists of techniques that are used by the attackers to destroy, abuse, or disrupt the normal behavior of the environment. The impact could be data destruction, or resource hijacking, or even denial of service. Understanding the attack surface of containerized environments is the first step of building security solutions for these environments. The matrix that was presented above can help organizations identify the security gaps in their defenses coverage against the different threats that target Kubernetes ecosystem. Now let's quickly look into some scenarios why Kubernetes has become a prime target for hackers and how hackers chain different attacks on the Kubernetes ecosystem in the real world.
This is a target web application which has a command execution vulnerability. We will be exploiting this web application, try to get access to the underlying server. For this, we will be starting the listener on the attacker machine. Go back to the application, enter the string which will connect to the attacker machine. Let's execute. As you can see, we got a connect back from the web application. Let's check the privilege of the user. Let's check, are we in a containerized environment or running on a physical server? This can be done by using mi contained utility. From the output you can see we are running on a Kubernetes infrastructure. Let's verify some environment variables. It confirms more. Now let's download the kubectl binary. Kubectl binary can be used to run the commands against the cluster. For any pod which is running in the cluster has a service account auto mounted in the default setup, and the service account has a role tagged to it. Let's verify which role is tagged to our service account in this pod. Kubectl auth can I list. This command will show the different privileges which are tagged to the service account. As you can see from the output, like we can create, list, update, watch, delete pods. Also there is one more privilege called pod exec. Using this privilege, attacker can jump from one pod to another pods. There's one more way to verify the same. Kubectl auth can I create pods? The answer is yes. Let's see, can we create the secrets? Kubectl auth can I create secret? No. So as you can see, we have compromised the pod from the vulnerable web application. Let's leverage this feature where the service account can create the pod in the cluster. We will be creating the crypto mining pod in the cluster. Let's look at the YAML of it. This is the YAML for the miner pod. We are pulling out the image K8s miner, which is a Monero pod. All the coins mined using the infrastructure will be uploaded to particular website using these particular credentials. As you can see, we have put down the limits on the memory and CPU just to remain stealthy. Otherwise the miner pod will consume the entire memory of the infrastructure. Let's copy this, go to the attacker access, paste. As you can see, miner pod is created. Let's verify it is running or not. Kubectl get po -o void. Yes, you can see the miner pod is running on the worker node. So till now we have seen we exploited the web application and compromised the underlying pod. We also started the crypto mining pod in the cluster. Let's see, can we compromise a master and worker node? Let's leverage the privileges which we recently grabbed it. For this we will be using a YAML definition file which has a privileged pod in it. Let's see the contents of the YAML file. As you can see, the first content in this file is for starting the pod on the worker node, and the second definition is starting the pod on the master node. The only distinguishing factors between two files is the node name equal to master states that this pod should start on the master node. If you don't define this parameter, it automatically lands on the worker node. Here we will be using different attributes in the YAML file, for example host path. Using this you can mount the file system or the base operating system in your pod, and then you can browse it. Then we also saying that run as a user 0, which means that start this pod as a root user, and this is the volume mount which you have created prev pod, and the same is there in pod which will be running in the master. Let's copy this. Let's copy this. I also have the dedicated slide discussing each attribute and the impact mapping. Let's go back to the attacker console, paste it. As you can see, the two pods are created. Now let's verify the placement of the privileged pods. As you can see, one of the pod is created on the master and one on the worker node. Let's exec into the pod which is created on the master node. Let's see the host name. We are on the master. Let's try to grab some of the files on the host. This is a shadow file of the host. You can crack the passwords in this file and then connect to the different nodes in the cluster.
Let's look at another interesting scenario where an attacker, after gaining access to the cluster, targets a crown jewel, the build server, which has privileged access to the code base, container storage repository and whole infrastructure, and how they can take the attacks to a different level. Let us assume that the attacker has gained access to the underlying pod using a web app vulnerability as seen before, and then the attacker will quickly download the kube control and then explore the pods that are running on the cluster. And then he comes across a container which is like a Jenkins, which is a build server, and checks if we can access that Jenkins server. And there we go, we got access to the Jenkins build server and we are running inside the cluster. Now let's try to grab the public IP address of the machine to access the UI of the Jenkins. Yes, we could access the Jenkins server. However, it is like password protected, but being an attacker, I just don't want to leave it there, but try to explore more and manipulate the configuration files to bypass the security mechanisms. I have made some changes to the Jenkins configuration files, and then I would like to restart the Jenkins to reflect the changes, or just delete the pod so that it will bring up a new Jenkins pod. Right, I'll go ahead and just delete the existing pod. And it should bring up a new Jenkins pod. And now let's see if we can access the Jenkins console again. There we go, we were able to bypass the authentication mechanism. And now let's create a new job, basically to grab some secrets and the environment variables. And I will just create a small build step which will run a quick bash command. I have like a set of commands which I will put into like the build stage, and I will save and run the build now. There you go, you now have access to all the environment variables, the secrets, and it says the Jenkins server is running with the root privileges, the ID root, and it also says like stealing AWS credentials. Now you have access to the whole infrastructure AWS, and if you happen to gain access to like the SSH credentials to the GitHub or the Docker Hub, you can create some malicious Docker images and you can push them to the Docker Hub using the Jenkins build server, or you can also make some changes to the code base, or you can just access the repositories inside the code base. Well, there is another interesting way of bypassing the security controls to avoid detection after gaining access to the cluster by just creating a replica or duplicating the API server. I have learned this technique from recent presentation of Brad Giesman, a well-known security geek. Well, after gaining access to the cluster, the attacker will quickly grab the configuration file of the Kube API server. And now let's create a duplicate pod with the similar configuration file with some modifications or some configuration changes in favor of the attacker, such as like opening insecure port or permitting anonymous access or etcd access. Well, now let's deploy this pod. we have the duplicate API server up and running, and let's grab the IP address of the API server. Well, that's the IP address of the duplicate API server. And now let's curl to the insecure port that we have exposed on port 443, and then try to access certain resources such as like the pods and secrets on the insecure port. There we go, and that's why it is called a game over. If you are planning on using Kubernetes in production, one of the key things to consider from a security perspective is the threat model. The application of the attack methodology on Kubernetes is something that everyone who uses Kubernetes need to understand. While Kubernetes has many advantages, it also brings new security challenges and risks and has threats in various forms such as external and internal attackers and vulnerable container runtime as seen now. And in addition to that, it has become a prime target for hackers because of the numerous moving pieces that needs to be secured inside the cluster. Now that we have understood the dangers facing our industry, and given the knowledge gap among teams and numerous resources that needs to be secured, you might be wondering how in the world are we ever going to secure all these moving pieces and stop these attacks? I had the same exact thought, and that's what led me to build a tool named Kubestriker that is designed to identify these misconfigurations which make organizations an easy target for attackers. And there you go. This is like the new and the improved version of the Kubestriker with a decent UI. It will give you all the information about the total number of clusters or the containers that are running inside all your clusters. It will show us information about the roles, misconfigured containers, etc. Now let's look at a scenario by adding a cluster, and it accepts Amazon, Azure, AKS, Google Cloud Cluster, and also you can add generic clusters such as like OpenShift or IBM or even like an on-prem one. So you can add a cluster by giving like the cluster name that needs to be scanned. And you need to provide an IAM role, which will have the privileges to reach out and scan your target cluster and the region where your cluster is located in case if it is an Amazon. Click on create. And usually the scan takes anywhere close to 9 to 10 seconds at this stage. And once the scan is ready, towards the right side of your screen, the total number will increase to 1. And within the next 1 to 2 seconds, it will come up with all the relevant information of that scan. There you go. It says like it has a scanned total 149 roles, out of which 113 are misconfigured. Like total 10 containers have been scanned, out of which 7 are misconfigured, pretty much like pod security policies and the network policies and the nodes where the cluster is running. And let's click on this cluster and let's deep dive into the demo or the reporting part. Well, it gives you like the version of the Kubernetes that is running inside the cluster and the version of Docker that is running on the worker nodes, and also like the same information like misconfigured roles, containers, pod security policies, nodes and scans, etc. Now, all the information, whatever we have seen using the CLI, it's displayed in a very appropriate way using like GUI. Under the misconfigured roles, it says like admin roles, read admin roles, destructive roles, secret roles, and all kinds of privileged roles. And it also clearly says this user web app in the namespace default has verbs star, which means actions, and all resources star, which means this particular user can access all the resources across the cluster. This is the reason why this is considered as admin role. And pretty much like a read admin role, the destructive role where the users have got delete privileges on the resources. This one says delete on secrets, and this has like delete on the secrets, pretty much. And the secrets role conveys that a particular user can get, list, and watch the secrets in different namespaces, and the PSP roles and the privileged roles. Now, if we look at the misconfigured containers, it says the containers which are like actually privileged containers and the containers where certain critical parameters are missing. And it would also tell you the reason why a container is called as a privileged container. If you click on one of the containers, it will tell you the reason why it is called as a privileged container. It will show you the flags. For this one, it says like the host network ID is set as true, and here it says like host PID has been set as true, and this is the reason why it has been flagged as the privileged role. Then it will list all the containers where the liveness probe is missing, readiness probe is missing, memory limits and CPU limits are missing, the priority class name has not been set, and where the secrets and the service accounts have been mounted. And then the misconfigured policies, it will tell you why a particular pod security policy is called as misconfigured, because if you look at this one, it has like all the flags just privileged as true, and it is running as any user, and allow privilege escalation is set to true, and it is letting to run or to deploy anything with all the capabilities. So like few other examples if you look at other pod security policies. And then the misconfigured network policies, and then it will list the nodes that you have running inside the cluster. It will give you like the operating system architecture site, which provides you a roadmap and narrates the journey of Kubestriker to date. It also gives you a detailed explanation of its capabilities, procedures, guidelines, and some handy how-to videos to make your life easier. Please check out the website as well and share your feedback. Innovation needs collaboration. So while the Kubestriker community of adopters and contributors are growing steadily, I hope to continue the expansion of its use by collaborating with more users and get more contributors on board. If you're keen to learn more and get involved, please get in touch with me through any of these channels. To sum up, I want to leave you with this. If you patch 99 vulnerabilities out of 100, it doesn't mean you're 99% secure, but still 100% vulnerable, because a hacker needs only one weak link to bring your whole system down. That concludes my presentation. Happy to take any questions you have.